Chapter 17, Communication and Internet Technologies. What are our learning objectives? By the end of this chapter, you should be able to show understanding of circuit switching, packet switching. This is on how the data is sent across the internet and how different ways of sending data. Understand why a protocol is essential for communication between computers. A set of rules, protocol. Why is it necessary? Why can't you just send the data without having to agree on any protocol? And understand how protocol implementation can be viewed as a stack where each layer has its own functionality. Is like a stack. The tools, and there are different protocols also, and they act as a stack, one above the other, where each layer in each layer has its own functionality, different functions. And you will understand the TCP/IP protocol suite. When they are selection, they are called the suite of protocols. Microsoft Office suite has Word, Excel, PowerPoint, all those things together is called the Microsoft Office suite. Show understanding of protocols, that is HTTP, FTP, all these things, BitTorrent, and their purposes. So those are the things we are going to learn. Section 17.01, transmission modes. There are two approaches, as I told you earlier, two approaches. One is circuit switching, the other one is packet switching. Packet switching, what happens is, there are different switches, right? Originally the telephone companies had like this. They were used in the traditional telephone system. That's a circuit switching system. It was called PSTN. What does PSTN stand for? Public Switched Telephone Network for voice communication. How? Here is in now this person to that person. Imagine that there's a telephone call, not a computer here. Now this is the today's situation. Earlier, this person wants to take a call to this one far away. There is no direct line from this one to that one, direct wire. Those days, there were only wires, wired communication, no wireless. Later only, the mobile phones and all that came, wireless. So here, this telephone has to go, this call has to go like this, go to this box here, switches, then it will switch to this one from there, from here to that one to here, this, that, finally to that one. But now they have become digital. Earlier they were analog, now they are digital, so that data transfer is also possible. Here is a diagram, circuit switch data transmission. Circuit switch data transmission. So it creates one circuit like this through these switches. So this is called circuit switching. The circuit or the path is called the circuit. Right? For data transfer to take place, the following has to happen. The sender provides the identity of the intended receiver. So now this is for data transfer, remember. So the sender must provide the identity of the intended receiver, just like sending a letter. When you send a letter, you write the address on the outside of the envelope. Same way here also you have to give the intended receiver's address. Then the system checks whether or not the receiver is ready to accept data. Sometimes may not be available offline. If that receiver is offline, then how to receive? If the receiver is available, a sequence of links is established across the network. That is like this to that point. This device to that device established. The data is transferred. Through this circuit, the data is transferred. The links are removed. Afterwards, after the call is over or the data transfer is over, these things are removed, put back to the original position, because the next connection may not be via the same path. The next call or the next data transmission may be some other path which has to be established that time. So there is no point in keeping this because the call is over or the data transmission is over. The links that are provided between the nodes are dedicated to one transmission. Only one transmission taking place at that time. There are no interferences with other transmissions. Same way a call. You take the call also those days. There is no interference from the others. Only that call. So the links that are provided between the nodes, this is a node, this is a node, are dedicated to one transmission. Channels, dedicated channels. They are dedicated channels, right? In shared transmission media. This is shared. The next call may be somebody else taking, or the transmission by someone else. Shared transmission media that guarantee unimpeded. What is meant by unimpeded is unobstructed transmission. When a telephone call has finished, there is a definite end to the call with removal of the links. However, for a lease line data connection, there might be a permanent circuit established. So there is another thing called lease line data connection, which you will have to pay a high price, a lot of money, and get it to yourself so that it will be just one circuit which is permanent. No other transmissions are possible through this. Excuse me. And that is the one that is dedicated for this transmission and for this user. No other user can use this circuit, as well as this circuit is only for these two nodes, nothing else. They are called dedicated or leased line. Very fast and lot of advantages on that, but very expensive. Then the next one is packet switching. First one was circuit switching, now the packet switching. Data transmission without a circuit being established. So there is a difference. There is no circuit, no one circuit, as we saw earlier. Data cannot be sent in a continuous stream. Instead, data is packaged in portions inside packets. Imagine that this is the file that has to be sent. Sent, but you can't send for various reasons. Maybe it's too big, Then what happens is they are broken down into small sections. They are called packets. They are packets. Now they are separate ones, of course, with a sequence number 1, 2, 3, 4, so that they can go along different routes, different circuits. Data cannot be sent in a continuous stream. Instead, data is packaged in portions inside packets. A header, which contains instructions for delivery. So there's a header and a body also. As well as data body. Let's have a look at the packet structure. A typical packet is split up to a packet header. That is this. The payload. This. A trailer. A tail, like, no? Head and tail. Trailer. What is going at the end. And the header has these 4 sections. What? Address. The IP address of the source means sender. Sender's IP address, receiver's IP address, then sequence number of the packet. I told you about the sequence numbers. That is 1, 3, 4, 5, 6, up like that. Or reassembly. Because once it goes there, because you are not sending them in one circuit, they are going in different circuits, like routes, different paths, different, right? Then you have to reassemble, put them together. So one should be one, and the first one should be first, second should be second, third, so on. So for that, this section has the sequence number and also the size of the packet in bytes. Then the payload is the actual data in the packets. Usually 64 kibibytes, the size. Then the trailer will have method of identifying the end of the packet. How do you know whether this is the end or whether there are some more bytes? Some form of error checking to ensure packet arrives error-free. Okay. Then for each packet, the packet header consists of, that's what I explained then, here, these things. Note, the header often also contains another value indicating how many packets there are in total for this transmission. So additionally, you might have how many packets are there. Now the size is given, but how many packets also may be given. And what is packet switching? Sending those packets in different routes like this. Let us now consider what happens when a photograph, for example, is sent from computer A to computer B. The photograph will be split up into a number of packets before it is sent. Like how I put here, number of packets. There will be several possible routes for the computer A, sender, and computer B, receiver. Each stage in the route contains a router, which finds the best route. A router. A router receives a data packet and, based on the information in the header, decides where to send it next. So when the router, now this one, sends one packet to this router. These are routers R1, R2. So then this one will decide, because it has to go to router B finally, from router A to router B, from computer A to computer B, to send it to this one, which is the best, whether to send it there, R2, R5, or R8. And from there, it will decide which one to send next. This is like the GPS system we have. We have when driving, we depend on the GPS. They're sending us through the best route, no? Congestion-free route. Here also a similar thing happens. So a typical network showing possible routes between A and B. So one is circuit switching, sending one packet or one load or one file in a established circuit. Here, small packets sent in different routes for the best optimum transmission. Then we talked about protocols. Protocol is a set of rules. A protocol suite which contains more than one individual protocol. So they're called a suite. There might be a number of different versions of a protocol also. Here is a definition again. A set of rules, protocol is a set of rules for data transmission which are agreed by sender and receiver. A protocol should define that a positive voltage represents a bit with value 1. So these are the things that are possible, right? Possible contents of the protocol. It might say that a positive voltage represents a bit with value 1. A transmission speed that a sender must not exceed, because if the receivers doesn't have the high-speed device, the sender sending at a very high-speed one will not be successful at the other end. So the receiver can tell receiver's device will make this protocol define the speed that a sender must not exceed. So the maximum speed, in other words. The format of a message or of a component of a message. You can sometimes, this protocol say, okay, I'm sending like this. For example, the first 40 bytes in a packet is the header or whatever the definition, we don't know. You and I don't have to worry about these things. These are looked after by the devices themselves. They are programmed like that, but we have to learn. We have to learn these things. Then what is a protocol stack? Protocols can be viewed as layers within a protocol stack. Each layer can only accept input from the next higher layer or the next lower layer. So one from this or this can receive from that or from here only, not from another one outside, only adjacent one, either up or down. There is a defined interface between adjacent layers, which constitutes the only interaction allowed between layers, right? So these three, the first three are the TCP/IP protocol suite. They are called TCP/IP. They go together. Two protocols, TCP. TCP means transmission control protocol. IP is internet protocol. They go together always, like the horse and carriage. So there is a interface between adjacent layers, which constitutes the only interaction allowed between layers. Only those are allowed. A layer is serviced by the actions of lower layers. Generally, it goes that way, servicing. With the possible exception of the lowest layer, the functioning of a layer is created by installed software. So what is the lowest layer? The physical, it's like hardware. All the others above that have the software. The installed software will look after those. The functioning of these layers. Layer may comprise sub-layers. There can be sub-layers. Any user interaction will take place using protocols associated with the highest level layer in the stack. So the user interaction with protocols, the highest level, the application. Any direct access to hardware is confined to the lowest layer in the stack. So anything to do with hardware, any business with the hardware is the lowest level. So here is the diagram. A network model relating to the TCP/IP protocol suite. Protocol stack for one end system. Then this is the stack for the another one. And in between is the protocol stack for a router. The router which will look after these two. Logical connections between corresponding layers in the above two end systems. These are the logical connections. An application can run on one end system and behave as though there was a direct connection with an application running on a different end system. So what is end system? We have learned that end system is like a user device or a PC or something. End system on a network, a node on a network, end system. That is the end of it, the user or the sender. The application layer protocol on the sender end system sends a message to the transport layer. The application layer protocol, where is application layer protocol? Here. Logical peer-to-peer relationship. We don't see these things, but from here, the one user here, the other user there, the other connection. Logical peer-to-peer relationship. The application layer protocol on the sender end system sends a message to the transport layer protocol on the same system. So when you want to send a message there, sends to the transport layer. Transport layer. The message, first of all. The transport layer protocol then initiates a process which results in the identical message being delivered to the receiver end system. So receiver end system is here. Transport only will look after that part. On the receiver end system, the final stage is the transport layer protocol. It is received here, delivering the message to the application layer protocol. Then it goes up and the user can see this. TCP/IP suite includes the following protocols. Application layer, HTTP, SMTP, DNS, FTP, POP3, IMAP. So these are the protocols. HTTP, as you know, Hypertext Transfer Protocol. So these things are given in your abbreviations file. You can look up that file to see whether you know these. First of all, you guess what these are. Write down and look at the abbreviation file to check whether you are right. Then another one in this suite is transport layer, TCP, UDP, SCTP. So this application layer has these protocols. Transport layer, second one has these, and the network layer, the third one here, has IP, IGMP, ICMP, ARP. TCP, Transmission Control Protocol. If an application is running on an end system where a message is to be sent to a different end system, the application will be controlled by an application layer protocol as described above. The application layer that will control this message. The protocol will transmit the user data to the transport layer. So as usual, as discussed earlier, transport layer. The TCP protocol operating in the transport layer now has to take responsibility for ensuring the safe delivery of the message to the receiver. So in the application, we saw the HTTP, those things are there to send, how we send the message to this one. Now, what is the transport layer doing? It has TCP IP. And the protocol will transmit the user data to the transport layer. The TCP protocol operating in the transport layer now has to take responsibility for ensuring the safe delivery of the message to the receiver. The TCP protocol creates sufficient packets to hold all of the data. TCP protocol creates sufficient packets to hold all of the data. So this TCP only will do that. And each packet consists of a header plus the user data that we already know. TCP has to ensure the safe delivery. The function or the responsibility of the TCP is the safe delivery of the message, that any response is direct, if there are any response is directed back to the application protocol. So it has to ensure that any response from the receiver, you have to direct back to the application protocol. So one item in the header is the port number, which identifies the application layer protocol. So there is a port identification, from which port did it come. For example, for HTTP, the port number is 80. The packet must also include the port number for the application layer protocol at the receiving end system. So for the receiving end system also, you need the port number for the application layer protocol. However, TCP is not concerned with the address of the receiving end system, but TCP is not concerned about the receiving end system, the port number, with the address of the receiving end system. If the packet is one of a sequence, the sequence number is included to ensure eventual correct reassembly of the user data. Sequence number we talked about. Is 1, 2, 3, 4, and all that have to be there in order to reassemble it. Then the IP. It is Internet Protocol. The function of the IP is to ensure correct routing over the Internet. To do this, the IP takes the packet received from the transport layer and adds further header. So from this transport layer, what is taken, IP will add another header. That header contains the IP address of both the sender and the receiver. To find the IP address of the receiver, it is very likely to use the DNS service to find the address corresponding to the URL supplied in the user data. So the URL will be like something like some address, no? ABCD at something like that. Or if it's an email, no? At gmail.com, whatever, that's a URL. And the internet doesn't know those things. So in order to get the IP address, Only IP address will be the real address. For that, you need the service of a DNS, domain name server. Domain name server. So these are servers around the world. Each country has more than one sometimes in order to provide these addresses. Otherwise, it will take a long time. There's only one server for the whole internet. It will take a long time for this translation. It's like a translation. If you say A, the IP address is this. If you say B, the IP address is that, like in a table. The data link layer assembles datagrams into frames. So those packets, they are called datagrams, coming in separate frames, separate packages. They are assembled into frames. To finally send it, they are sent like frames. IP functions as a connectionless service. That is, once a packet has been sent, IP will have no knowledge of whether or not it reaches destination. So it's called a connectionless service. Doesn't know, just passes it on. If IP receives a packet which contains an acknowledgement of a previously sent packet, it will simply pass the packet onto TCP with no awareness of the content. So the TCP only will look after that part. Beyond that, the IP doesn't know whether it received or not. The router. Function of the router software is to choose the next target host in the transmission. We discussed this earlier, like the GPS. It finds the next target host in the transmission, the optimum one, the best one. The software has access to a routing table appropriate to that router. So the software has access to a routing table. So from that table only, you select which router to send next. The routing table for every router has details of any current problems with any of the options for the next transmission step. That means current problems means if there is a congestion, if it is taking time, or if it is blocked, or if there is a breakdown or something, that detail is also included in this table. That will help to find the next node or the best route. You should not send through that blocked one. This ensures that packets are delivered to their destination in the shortest possible time available. So the quickest one will be found because of this. Why? There is a delay, you won't send it through that router. Just like GPS, there are many routes from A to B when you travel, but it will select the best one for you and say, go this way. And you save time. And also if everyone uses GPS, there will be minimum congestion because the GPS will send you one here, one there, and again here. All the traffic will be uniformly distributed along the routes so that there will be minimal congestion or equal. If this route has a delay, that same delay will be in the other route and the other route. So that is why it's important that all should use GPS, whether you know the route even if you go every day, if you use the GPS, that will help to ease the congestion. Now the Ethernet protocol stack, it can function in an isolated LAN, local area network, with no connection to the internet or any other network. So it can be a isolated LAN, isolated meaning without connection to the internet. So the sublayers of Ethernet The Ethernet protocol, that's also a protocol. Sublayers, we mentioned earlier, there can be sublayers. No? So these are the ones, LLC, MAC, PCS, PMA. The logical link control should be LLC, logical link control. Protocol is responsible for the interaction with the network layer. It manages data transmissions and ensures the integrity of data transmissions. LLC, logical link control. However, because Ethernet is a connectionless protocol, it has no responsibility for checking that a transmission has been successfully delivered. So that is also the connectionless thing, doesn't know whether it was delivered or not, but it does the function. The medium access control, that is MAC protocol is responsible for assembling the Ethernet packet, which is referred to as a frame. Assembling the Ethernet packet, which is referred as a frame. Two components of these are the address of the transmitter and the address of the receiver. Packet, like we learned in the packet headers, the components, sender's address and the receiver's address. In addition, the MAC protocol initiates frame transmission, and handles recovery from transmission failure due to a collision, possibly using CSMA CD. Remember this? Collision detection, right? CSMA. Again, you can check whether you remember this abbreviation. We have done this. And see whether you can remember. Think well. Think well. Thinking will improve your brain. The physical coding sublayer, PCS. That is this, after MAC. So first we have the LLC, then the MAC, and then PCS. The physical coding sublayer. PCS protocol is responsible for coding data ready for transmission or decoding data received. It either receives a frame from the MAC protocol or sends one to it. So either receive from MAC or sends to MAC. The physical medium attachment, PMA, the last one. Physical medium attachment protocol is responsible for signal transmitting and receiving. So the physical part, signal, sending a signal and receiving a signal, that is looked after by the physical medium attachment. MAC addresses, there's a thing called MAC address. A MAC address is the one which uniquely defines one, what is NIC? Network Interface Card. This is necessary in every PC for a network to be connected to a network. This NIC, Network Interface Card, is necessary, and it has a unique address. No two PCs in the world will have the same NIC or NIC. For that, 48 bits are used. 48 bits means how many bytes? 6 bytes. And the first three bytes identify the manufacturer. So each manufacturer has, so the computers of one manufacturer will have these first 3 bytes the same. These are hexadecimal digits, right? Hexadecimal digits, 4A, 3012. First 3, that's a manufacturer. The last 3 bytes identify the device's serial number. So the last 3 is the serial number of the device. 24 1A 10. So that will be by one manufacturer. You will have these serial numbers. Serial numbers can be the same in two manufacturers because they start go on. But because this manufacturer segment is different to each other, each manufacturer, this will become unique somehow. Even these three are found in different manufacturers. Some devices, this can be found. There can be two devices with the same serial number, but with this, it becomes unique. Then comes application layer protocols associated with TCP IP. HTTP, Hypertext Transfer Protocol, the most used application layer protocol. Every time a user accesses a website using a browser, HTTP is used, but its functionality is hidden from view. You don't know. You don't know actually what is happening, but Hypertext Transfer Protocol will do the function. Every time a user accesses a website. So in browser, if you will notice that HTTP or HTTPS is there at the beginning, the URL. HTTP is a transaction-oriented client-server protocol. Transaction-oriented. There's a request, the message requesting from the client to the server, and the server will respond with another message. HTTP protocol defines the format of the message. The format of the message is also defined by HTTP. The first line of a request message is the request line. So the format is method, URL, version, and CRLF. Method maybe get, right? There are different like post, get, and all that method. Then URL, you know, the google.com or whatever that URL. Then the version equals HTTP version. Right? And the CRLF is, CR is a carriage return. It's an ASCII character for that. Then LF, line feed, ASCII. Okay? CRLF, that is the end of it, like the enter key. After typing something, when you press enter, that's the end of it. Optionally, this can be followed by header lines. Then comes email protocols. So email protocols, there is the two systems are here, the two servers. Then email sender client, this email sender client using SMTP. Mail server, simple mail transfer protocol, SMTP. This is a mail server. So the user sends to the server becomes a client for this server. Then through the internet, it goes to the receiver server. Then the server will give the user, the receiver, the email receiver client. Then using this POP3 is post office protocol 3, it will download in the mail server. These two are the mail servers. SMTP is a protocol in between. An email message being transmitted from a sender to a receiver. Three individual client-server interactions are involved. What are they? The email sender acting as a client, has a connection to a mail server this way. This server then has to function as a client in the transmission to the mail server. So then this server acts as a client to this mail server used by the email receiver acting as a client. So So this becomes a client to the receiver's server. SMTP push protocol. Push protocol. It's called a push protocol, SMTP. And POP3 pull protocol. So SMTP sends, POP3 receives. Pull protocol. Download onto client receiver PC. Like Eudora. Those days it was like that. POP3. The famous one was called Eudora. Software for the email. IMAP. Recent alternative. Recently it came. Not downloaded, remain on server, but accessible. So unlike POP3, it doesn't download to the server. It remains in the server. Download to the receiver, receiving client, but it remains in the server in the IMAP. That's called internet-based mail. Again, POP3 downloads the mail to this client and then deletes from the server. It's not available there anymore. It's downloaded physically to this client. Then without going into internet, the receiver can look at the email. Only when you want to send again or receive again, you have to connect to the internet. But whereas this IMAP allows you to have it there without downloading it to your computer, you can access at any time. That is like Gmail. It can be argued that POP3 is more secure to cyber attack because emails are locally stored. However, the server will be backed up regularly, whereas the local client might not be. So though it is best because after downloading to your computer, no one can access it. But on the other hand, server, when the mail is there, it is backed up regularly, but you don't do it, you and I. The major advantage for IMAP is that the server can be accessed from any client. So what that advantage is, where you don't have to carry your computer everywhere you go to access your email from any computer, any device, anywhere in the world, you can access it, right? Whereas POP3, with the POP3 download, if you go somewhere, you have to carry your computer because the mail is already downloaded and deleted on software. The mail will be found only on your computer. This makes it suitable for anyone on the move or if someone is using a system other than that normally used. So POP3 emails are only accessible from the one client system. So the POP3 emails are only from that client system available. You can't access it from another computer. SMTP has been largely replaced by the use of web-based mail. Web-based mail. A browser is used to access the email application. So HTTP is now the protocol used. However, SMTP remains in use for transfer between the mail servers. So for the transferring part, it remains the SMTP. But then that this and this is replaced by the HTTP, the web mail. Then FTP. FTP is file transfer protocol. The application layer protocol that can handle any file transfer between two end systems. File transfer is not simple if the end systems have different operating systems with different file systems. What does that mean? File transfer is not simple if the end systems have different operating systems with different file systems. So file systems are there. When you format the hard disk, it will tell you what the file system is. Then also operating system. One is a Mac, the other one is a Windows. Likewise, then it's not so simple. So FTP handles this by separating the control process from the data transfer process. So FTP will handle that part. Peer-to-peer, P2P, in short, file sharing. Peer-to-peer file sharing is one of the main features of internet use. P2P is an architecture that has no structure and no controlling mechanism. The architecture that has no structure and no controlling mechanism. Peer-to-peer. Peers act as both clients and servers, and each peer is just one end system. When a peer acts as a server, it is called a seed. If you have used these BitTorrents, torrents, then you will know what a seed is and what a peer is. So the client server both can be the same. BitTorrent, most used protocol. BitTorrent is the most used protocol. It allows fast file sharing. Fast file sharing. You already know it, how it does happen. Very popular. How it is shared, not from one place to another. The file is shared and downloaded from 2, 3 or more different places, so it becomes fast. But there are problems. What are they? How does a peer find others that have the wanted content? One wants something, and how does a peer? How does he find out who has the wanted content? Every content provider should provide a content description called a torrent, which is a file that contains the name of the tracker, the server that leads peers to the content, and a list of the chunks that make up the content. The torrent file is at least 3 orders of magnitude smaller than the content, so can be transferred quickly. So broken into smaller packages. The tracker is a server that maintains a list of all the other peers. The swarm. Those who have done this will know these terms. Swarm. All the other peers. The tracker will know. Actively downloading and uploading the control. So currently at the moment, right now, who are the peers who are actively downloading and uploading the content? Then the second problem is, how do peers replicate content to provide high-speed downloads for everyone? Peers download and upload chunks at the same time, but peers have to exchange lists of chunks and aim to download rare chunks for preference. So they download and upload at the same time, right? The peers. Each time a rare chunk is downloaded, it automatically becomes less rare. So if it's a rare thing, and if you download, and more downloads will make it less rare. That is the usage. If it is not used for some time, it becomes rare. When it becomes used very frequently, then it becomes less rare. How do peers encourage other peers to provide content rather than just using the protocol to download for themselves? How do you encourage the other peers to provide content rather than just using the protocol to download for themselves? So otherwise, if you don't encourage, some only download. So then few givers and more takers, few uploading and many downloading. This requires dealing with the free riders or leechers. They are called leechers, who only download. The solution is for a peer to initially randomly try other peers, but then to only continue to upload to those peers that provide regular downloads. You can say, if you upload only, you can download. If a peer is not downloading or only downloading slowly, the peer will eventually be isolated or choked. So That is the end of it. And here is a summary. What have we done? Circuit switching requires a dedicated circuit to be established between sender and receiver before transmission can start. In packet switching, packets can be transmitted without any circuit being created. Circuit switching, we have to create a circuit, whereas packet switching, no established circuit, packets are sent through different routes. Packet switching can be connectionless or connection-oriented transmission. A protocol suite is implemented as a layered stack, layer by layer. The TCP/IP protocol suite supports usage of the Internet. Ethernet is the most likely option for use in the network and data link layers. Examples of application layer protocols are HTTP, SMTP, POP3, IMAP, and FTP. Peer-to-peer file sharing on the Internet uses the BitTorrent. Peer-to-peer file sharing on the Internet uses the BitTorrent protocol. That is also another protocol. So that is the end, and hope you learn this. Replay, watch over and over again until you master this. It is very important that you do the exercises given, the assignments, right? So see you next time for the next lesson. Bye.